Hi, I'm Teacher Thomas. Welcome to Math Class. Today's topic is integration, volumes of revolution. This question is from the June 2020 A-Level 9709 Pure Mathematics 1, Paper 11. We have a diagram and we read. The diagram shows part of two curves, or one curve and one line, intersecting at 2 points. The point C lies on the curve, and the tangent to the curve at C is parallel to AB. Requirement A, find by calculation the coordinates of A, B, and C. B, find the volume generated when the shaded region, bounded by the curve and the line, is rotated through 360 degrees about the x-axis. I'm going to write up the solutions for A, not the workings. You can find points A and B using algebra with simultaneous equations. You can find point C using differential calculus. These points are A is 0, 4. B is 6, 1. And C is 2, 2. We're going to focus on requirement B relating to the concept of volumes of revolution. I'll post the formula for volume of revolution on the whiteboard. And here we have volume is the integral from A to B of pi times the square of the function with respect to x. In our example, the shape that we're rotating is formed by two different functions, so we're going to use subtraction, and I'll set up my calculation as volume equals the integral. Our A to B, we've identified the x values of A and B as 0 and 6. We're going from 0 to 6. We have pi times our first function is the higher function. We can see on the graph that the higher function is 2y plus x equals 8, which I'm going to rewrite as y equals 8 minus x over 2. And that's going to be the function that I will square. So I have quantity 8 minus x over 2 squared. I will then subtract pi times quantity. My other function, the lower function, is 8 over x plus 2. I square that with respect to x. Notice that we are not taking the square of the subtraction. It's not high function minus low function squared. It is high function squared minus low function squared. Now, before the integration, I'm going to do some simplification. I'll take the pi outside of the integration since pi is a multiple of both expressions. So we have pi times the integral from 0 to 6. 8 minus x squared over 2 squared is 1 over 4 times 8 minus x squared. Minus, and that pi is now outside of the integration. 8 over x plus 2 squared is 8 squared, which is 64, times x plus 2 to the power of negative 2. I've taken x plus 2, which is squared, out of the denominator, put it into the numerator. Thus I'm using a negative exponent with respect to x. From here, one option I have, which would simplify the calculus but would take a lot of work, would be to do all of the algebraic expansion and combine like terms. Instead of doing that, I'm going to go with my integration. I have pi applied to the integration of both terms. First I have 1 over 4 times. Now the integration of 8 minus x squared, I'm going to keep 8 minus x. I'll increase the exponent by 1. I'll divide by the new exponent. and I also need to divide by the derivative of the inner function. This is like a reverse chain rule concept. So the derivative of the inner function, 8 minus x, is negative 1. With the chain rule in differentiation, I'd multiply. In this case, I'm going to divide by negative 1. So I'm dividing by the 3 because that's my new exponent. I'm dividing by negative 1 because that's the derivative of the inner function. Minus 64 times. Similarly, I will take my expression x plus 2 to the power of negative 2, increase the exponent to negative 1, divide by that new exponent, and also multiply by the inner function of x plus 2, the derivative. I'll multiply by the derivative of the inner function x plus 2. That derivative is 1. We're evaluating on the interval from 0 to 6. One more simplification. Pi multiplied by, now I have 1 over 4 times a denominator of 3 times negative 1, which will give me negative 1 over 12, and I'll have a numerator of 8 minus x cubed. The second term, minus 64 times a denominator of negative 1 times 1, becomes plus 64. And the denominator will be what we have as a numerator now, x plus 2 to the power of negative 1, a denominator of x plus 2. Again, on the interval 0 to 6. And when I evaluate at 6, and then I subtract the evaluation at 0, all multiplied by pi, the value is 18 pi. This is a three-dimensional figure without unit of measure. Units cubed. This completes our requirements, and this completes the lesson on integration, volumes of revolution.